So we are Top Hat Hardware Design. My name is Michael.
I'm Pavel.
Jesse.
Keith. I'm Sean.
And so our product is an air quality detector. Basically, for our project is most air quality detectors are kind of expensive, especially like the accurate ones, like the Dallas. So our product was to be comparable to the Dallas in both accuracy and in basically ability to measure the concentration of particles in the different sizes. And so we made a product that was both cheaper and comparable in quality, and we're also able to transmit all the information over Bluetooth.
So the sensors that are involved for us, we use the Amphenol sensor for the dust concentration, actually for the dust particle concentration. And in order to make our readings a little more accurate, we also included the humidity and temperature sensor, so we can modify our Amphenol data so that our data about the concentration is a little more accurate. In addition, to make the sensor a little bit more robust, we also added the CO2 sensor. The idea is to have it run remotely somewhere for a pretty extended period of time on battery, and be able to transmit the data that's ready on a phone, whoever needs to get the data.
And so this is our 3D render of our release design. We have our PCB shown in red and the CO2 sensor here as the circle. We also have the Silicon Labs temperature and humidity sensor on the PCB, as well as our Bluetooth BLE. And here is our Amphenol sensor, and we're also going to be connecting with our CY Smart phone app with Bluetooth Low Energy.
You guys want to pass that around while you talk?
So for our system, it has power through a battery, a rechargeable battery that is inside the unit. It also has the ability to be hooked into a USB port. Uses a standard size USB. From there, the power is put into a battery management IC. This IC determines that if the battery is low, it will charge it. And also directs the power to our two regulators. Our 5-volt boost, it converts our input voltage, which is in the range of 3.7 to 4 volts to 5 volts. And also our 3.3 regulator, which brings down our voltage to 3.3 volts.
So this is our basic layout. Right there is our dust sensor, temperature, humidity, CO2, and our Bluetooth is actually part of the PSOC chip now. And yeah, that's PSOC's new BLE chip.
Okay, and so here's an overview of the sensors. The Amphenol is used to detect dust particle concentration. It detects small particle and low particle. The COSR is our CO2 sensor, and the Silicon Lab sensor measures temperature and humidity, and it's used to calibrate our Amphenol dust sensor, which is humidity dependent.
So this is our state machine. Basically, we start up, go into standby mode where it receives data, or it takes in the new command. Then it goes to a read cycle for dust. It reads temperature and humidity to get that value for our later data editing, and then it transmits. There's also a step in there for CO2 reads, but basically the transmit data stage, the BLE has a predefined data set that it broadcasts, and then it goes to sleep.
So when we took the power measurements of our system, we found out that the Amphenol sensor pretty much dominates the power consumed by our unit. The smallest amount came from the COSR. It required almost no power to be consumed to use it. That's pretty much it.
In a full screen that too.
Particulate matter refers to a wide range of particles that are small enough to be carried by the air and be inhaled by people. It can be a solid, liquid, or a mixture of both. These small and almost undetectable particles are both hazardous and pose risks to human health. travel deep into our lungs and cause permanent damage. The smallest of these particles can enter the bloodstream and even cause heart problems. To address this issue, we have created an air quality detector that can measure both concentration and different particle size. Introducing the air quality sensor by Top Hat Hardware Design. While most air quality detectors are expensive, we have provided a cost-effective sensor without trading off functionality. Our product uses a dust sensor that differentiates between 2.5 and 10 micrometer particles and includes a temperature, humidity, and CO2 sensor, allowing for both more informative and accurate readings.
In addition, our detector is equipped with Bluetooth capabilities to broadcast the readings wirelessly. With this product installed in your home or at work, you can always be aware of the air quality around you, as well as your health.
Great.
So you said that it was better than another product that was equivalent to what you made, that is currently being manufactured in.
Yeah, so there's another product that we are trying to compete against, and their product is about $200. So ours has a cost that's about 4 times less than that. The resolution isn't as great, but it's very close to what our competitors have for their device.
What kind of case did you do to confirm that? Can you elaborate a little bit more?
So I was testing outside, testing it indoors, putting various smokes and various particles throughout the apparatus. And so basically, I'm comparing the expensive sensor to our amphenol and dust sensor, and I'm collecting data, and then I'm interpreting the data and correlating the output of the amphenol to the output of the dilose, and I found a relationship between both, so that like I can interpret the data sent from the amphenol similar to the data that I would get from the dilose. So we're incorporating sort of like the dilose scheme within the amphenol, a cheaper sensor.
And did you purchase the other product just to kind of compare and contrast as it went?
It was already purchased, so yeah.
We already had it for the morning.
Oh, okay.
So why do you need to monitor the humidity and the temperature as well for your product?
So the amphenol sensor runs off a photodiode type system, whereas the dilose runs off a laser system. The photodiode system is dependent upon humidity. The higher humidity, the more light's going to scatter, which gives a skewed result. Also temperature. A change in temperature actually affects the diode. The photodiode. So by having the temperature and humidity calibrate, we can use the temperature and humidity that we gather and use that to get better results from our device.
Other questions?
How does air get in your box? Is it
So on the back we have a hole, and from there, inside the sensor, there's a resistor that will pull air in, and then because it warms up the air, and then it'll push it out to the top of the sensor.
Very good. Thank you.